And next we have Andrey Borodin, who's here to talk about multi-threaded Postgres connection pooler called Odyssey.
Thank you, Aaron. Hi, everyone. My name is Andrey, and I like to work on Postgres. And let's talk about transaction connection pooling and news in this field. Few words about me. I'm hacking on Postgres since 2016. My first patch was committed to Postgres 10. Also, I maintain Odyssey connection pooler, as you maybe noticed, and also maintain a backup system ValG, and sometimes contributing not just in Postgres and in Greenplum too. I'm working as a team lead at Yandex Cloud. We have a huge workload based on Postgres. We have petabytes of data, and the clusters vary from very small to very big, and we kind of working for making each one better. For example, we have a Yandex Mail with serving for about 500 million of mailboxes, or Yandex Cloud Object Storage serving 1 million requests per second for different file variants from teeny few byte files to multi-gigabyte files. And typical setup of our cluster for our services looks like this. This is a highly available cluster with usually 3 nodes, and each node has a connection pooler, which serves as a optimization technique and also as high availability fencing, but there will be not much in this presentation for this. Also, we have a logical replication passing through Odyssey, passing through connection pooler to analytical system, and we serve read queries from standby nodes. This is basically our architecture from bird's eye view. And typical application have a load balancer with on top of many application backends, and each application backend has its own connection pool on application side. That's why typically we have a lot of connection that is going on to the database. And Postgres is OLTP database. It maintains a snapshot, and many snapshot operations depend on linear scans through proc array, which have an entry for each connection going in this database. It's why we want to keep the number of connection to the database as small as possible, while actual number of connections can be quite big. There were recent improvements in the area of connection scalability, mainly development in this area is led by Andrey Aaron from Citus, and there is a huge developments. Connection scalability is becoming better and better, but still, the more connection you have, the slower performance of a database on peak loads you can have. Also, there is a interesting work, related work in built-in connection pooler by Konstantin Knizhnik, but this work seemed to be slowed in recent years, and there is no much hope when it will be committed, when it will be usable with upstream Postgres. So, to the date, using a connection pooler in OLTP-oriented workload is a necessity. You just can't avoid it if you want to get as much efficiency as possible from your hardware. That's why I'm working on Odyssey. Odyssey was introduced in 2019, and the main idea was to be like multi-threaded PG Bouncer. PG Bouncer is a great piece of software. It had accumulated years of developers' wisdom, and we liked it very much, but it was single-threaded. And the point of release Odyssey 1.0 was to solve the problem of single-threaded PG bouncer. You can use PG bouncer with port reuse, but this construction is really difficult to maintain. Then we have Odyssey 1.1, which mainly was just catching up with PG bouncer, making the connection pooling the way PG bouncer does it, like adding delays where they are necessary, adding slowdowns where they actually are necessary. For example, Odyssey 1.0 used to grab as much server connections as it wants, and on synthetical tests this performs just fine. But in PG bouncer there is a small slip before grabbing each new server connection, and actually it was a lot of wisdom in these decisions. And we re-implemented many of slips that PG bouncer had to make Odyssey more stable and better pulling transactions. Also, we added better observability in Odyssey 1.1. You can get statistics not about average number of transactions or not about average latency of a transaction, but on transaction quantiles like 1% of the slowest transaction or 5% of the slowest transaction fit in this timing. Next release was again catching up with PG bouncer. We had to implement widely used pluggable authentication model, and we had some security issues we had to fix in a host-based authentication. Also, we added Prometheus integration. And now we are on track to have Odyssey 1.3. And in this release, we are going to have 2 new features unique for Odyssey, and I think first time in history of Odyssey. This is features which you cannot find in any other transaction connection pooler, and probably any other pooling software for Postgres. And let's discuss these features in more detail. By the way, this release was mainly developed by Kirill Reshke. He was co-author of this talk, but unfortunately, he is now on ICPC competition and on half finals in Northeastern region. So I'm presenting his work to you. Anyway, I took part in this, so I think I know how it runs. This is another picture of Kirill. He is more like in his vibe of hacking for Postgres. Let's talk about standby lag polling. What's it for? In this architecture, you have standbys. They are here for high availability, like you can fail over primary node to any standby in a quorum replication. And these standbys also can be used as hot standbys for executing read-only queries. And this allows you to do not waste a lot of hardware only for reasons of high availability. But you need to connect to correct node, and to do this you are using a technology which is called multi-host and target session address. In the connection string of Postgres, you can specify many host names with ports and say what level of connection do you want. You may say that you want standby, you can prefer standby, but there is no standbys, you want primary. You can say that you want just any alive host, any host that can respond to queries. You may want strictly primary because you want to write data into your database, and many other functions. This technology works just fine in so many setups, so our service developers are accustomed with this technology, but suddenly there are some problems. because you are using high availability cluster, some node may fail. For example, hypervisor may be turned off to replace memory, or RAID array of SSD drives may degrade or fail entirely, or network can be partitioned and data center can be disconnected, or power can be lost, and many other failures that are just okay for a highly available cluster, but when the power is restored, or maybe hypervisor is replaced, your database wakes up with a huge lag behind the primary node. It is showing you very stale data. And if you use target session address, you may read this old stale data. Ideally, we would like to implement so-called read after write consistency. So guarantee the user that if she is issuing write query, she will be reading read query for some time after this, and this time should not be less than a lag. But we did not implement this read after write consistency yet, but we are moving towards this. We had implemented lag polling. What does it mean? When you specify a Postgres server in a Odyssey config, you can say that you connect to that host on that port using these credentials, etc. And you can specify so-called watchdog. Watchdog is a query that will be executed against the server every watchdog lag interval and asks the server what is the time of last replication record that you applied. And so basically, this is how new is your data, and the server will reply with a timestamp in Unix timestamp, saying the second at which his data is currently, and Odyssey will remember this time, and every time user want to start a transaction, Odyssey is going to take a server connection unless the server is lagging behind. For each pair of user and database, you can specify so-called catch-up timeout. This is a time of a lag that can be, this is a maximum difference of real-time clocks on a client and time of last applied replication record. If the user is trying to get a server connection for a new transaction and the server is behind this time, then we will wait for catch-up checks. And if the server do not catch up, we will return error to the client saying that, sorry, this server is just stale, you can't read from here. This feature is designed to work with target session address. So if you specify host names in the order of network latencies, network round trip time from a client to server, and nearest server to you is lagging too much behind the primary, you just pass it and try next server. If the next server is lagging too, you just pass it and try the next server. Eventually, go into the primary, and the primary has always zero lag. So if you just can't connect standby, read-only standby, eventually you will get to primary node if any host in your installation is live. That's how it works. You can try it. And let's move on to the next feature. And next feature is so-called prepared statement pooling. And I'm especially proud for this feature because in PG Bouncer documentation, it's described as impossible feature and yet it's possible. We had implemented it. How it works? There are two ways to issue a prepared statement. There are three ways to issue prepared statement in Postgres. First one is so-called prepared transaction. This feature is not about prepared transactions. The other is prepared SQL level prepared statements, which must be prepared within query. And Odyssey do not parse queries. We cannot control SQL level prepared statements. And the third one is a protocol level prepared statements that are issued by your driver, PGX or JDBC or npg-SQL or whatever you use to work with Postgres. This is so-called extended protocol. And how it works? First, client issue a front-end message parse, and parse is saying, remember that PS name is following SQL command, and this command may have some parameters. Next, client issues bind PS name to parameter values. Here you bind parameter 1 to number 31,337. And then you say that describe, execute, close things. This is just saying, give me my data with these parameters. Why this sequence of commands may be of use? Because during the parse message, planning happens. And planning can take a lot of time for like working with statistics and parsing your query and checking it against system catalog and checking against your data, etc., etc., etc. But you can parse the statement once and bind, describe, execute, close, and sync many times. It save you for time for planning and save you time for parsing and save you CPU time. This pattern of using can save you CPU time. But the problem is when you issue sync, typically your transaction is over. The server will respond already for query, not in transaction, unless you open a transaction explicitly. So prepared statements are designed to survive the transaction boundaries. But in transaction connection pooler, nothing must survive the transaction boundaries. That's why this feature is described as impossible in PGBouncer. How we did this? Before this feature, there was 0 hash tables in Odyssey. I'm personally fond of hash tables, and I was somewhat surprised by that we could achieve so much functionality without single hash table. But now we have 2 hash tables. One hash table mapping prepared statement name given by client to SQL hash, and this hash table belongs to client session. The other hash table is a mapping of SQL hash to prepared state name known to each server connection. And then when the client is issuing parse with client prepared statement name and SQL command, what we do? We do not send to server anything. At this point, we just this command affects only state of the Odyssey. We hash SQL command to command hash, and remember that when this client wants this prepared statement name, in fact, client wants this SQL being prepared on the server, this SQL hash prepared on the server. When the client is issuing bind, we are already connected to some server, and we look up by hash of SQL how this prepared statement name is known to the server. And if the server doesn't know this prepared statement, we injecting prepared, re-injecting parse message with preparation of this prepared statement under new generated server name. And then we actually bind this prepared statement to client parameters. This is how it works. I hope it will be useful for someone. There are some downsides. For example, server's hash table will hold the name of prepared server forever, and server backend will hold this statement prepared forever. Not actually forever, but until server lifetime expires. In default configuration, Odyssey have a server lifetime of 1 hour to clean caches, to clean plan cache, to clean cat cache, to clean rel cache, and many other caches. So I don't think it will be a very big problem unless you have so many different prepared statements. For example, you can have a combinatorial explosion with a type of parameters, because types of a parameters are considered part of a SQL query too. They distinguish prepared statements between each other. Other downside is that mapping consumes memory, and hashing of SQL takes some time. Actually, when the client is issuing prepare, it just takes time to hash. We use quite efficient hash, so we expect this don't be a big problem, but it will allow new workload to work with prepared statements and transaction pooling. You can try both features in our new release 1.3 release candidate. Fortunately, it's still a release candidate. We tried this version in production. It under certain load, it has a very rare bug, making very slow connection to HAN. After hunting this bug down, we will publish 1.3 release without release candidates node. But right now you can try and test drive the feature with a release candidate version. If you have some ideas, what kind of fantastic and difficult, or maybe insane, maybe strange, maybe interesting features we could have in Odyssey 1.4, please ping me on Discord or in Telegram or email or in GitHub or whatever. We are looking for interesting features in Odyssey, and we really like new innovative stuff here. And basically, that's my talk. And thank you very much for listening. Scale connection pooling, scale Postgres, use Citus, use open source. Thank you very much, and I will be happy if there are some questions.
Thank you very much, Thomas. That was a very interesting, sorry, Andrey, thank you. It was a very interesting talk with a lot of deep technical detail, which I was really fascinated by. Somebody who was saying, this is very cool work. I'm keen to dig into the read-write consistency stuff and understand more about this. So there's lots of things there.
We are looking for read-write consistency and some other models of consistency, but currently, we don't have a way to understand was your query writing or reading. If we will learn how to analyze this, we will be able to remap client connection on primary server, or bind client connection for primary server for a time. But at some point, prepared statement pooling was looking like impossible feature too. I hope this will be the case of read-write consistency, but now it's impossible, and I don't know how to do this.
Fun challenges. And I noticed as an open source project, it's quite popular. And I'm curious a little bit about some of the features that you might have implemented on behalf of the open source community. Do you have any of your sort of favorite features or features that have come from particular use cases from people using it in the open source?
Yeah. You have basically two ways to authenticate in Postgres. You have three ways to authenticate in Postgres with password. One is completely wrong. This is plain text authentication when you send your secrets or the encrypted network, but it's just don't do it. And another way is to use MD5 hashing. This means that if your Odyssey configs are stolen, you cannot immediately log into the Odyssey, but you can put some computation pressure and you will hack this. Hack these hashes and will be able to enter later. And we implemented MD5 in Odyssey, and the community implemented Scram. I'm not sure how to correctly pronounce it. This is a way when if you stole Odyssey configs, it doesn't give you anything, and you cannot reuse it to log in into database. And you can guess real passwords with much bigger computation power. That was a community work. Also, a community implemented first version of standby log polling, and we were working on merging it for quite a long time. But we had to Kirill had to re-implement from the scratch because, like, there was development of other features, and at some point, developer of standby log polling was not working for this, and we had to re-implement this. And there was one more feature that I can't remember. It was quite big. So, well, community is working with us too, and we are happy with this. And we would very welcome pull requests. By the way, we really need the documentation. Our documentation is so much. Like sometimes I just can't remember myself how this works and want to read this somewhere, and I have to cope with source code. The documentation contribution would be super cool.
Yep. I find a lot of people when there's a project which is maybe moving very fast, often look at the tests to kind of look at various features. Is that something that you would recommend, or is that also something maybe people could contribute to? But what are some good entry points for people understanding the code base?
We have two kinds of tests. We have unit tests, and we kind of we're not implementing new tests for a few years now. And we are writing a Go-based tests, which are basically programs that emulates bugs. And that Go part is much easier than C part.
Yes.
Because you can see that how the protocol is used to interact with Odyssey, and you can create a difficult situation. And right now we have some tests broken. I hope we will fix it before release. And this is always the beginning of a contribution to just fix some tests.
Yes.
Unfortunately, some tests result in difficult race conditions. Some tests are just easy to fix because it's oversight, and some tests are strange race conditions, which is difficult to tackle. And I don't know which one is which one is easy and which one is not.
Reminds me of problems you see in Kubernetes space. I'm also a Go developer myself, so this immediately makes it more accessible to me than the C and the lower level things. It's nice to see, and it's really good for obviously network level programming and all of those sorts of things. So it's good to know. I'd have a poke around at the source code later. So if you have any more questions for Andrey, please join us in the Microsoft open source Discord at open-source-discord. I've seen some fantastic conversations going back and forth, including some security related. And I hope we will see people joining us also for the wrap up very shortly. So we have a half-an-hour wrap up with Claire Giordano and Thomas Monroe, myself, talking about this and many of the other fantastic live sessions we've had today. Yours is the the wrap up for the APAC session, Dre. So thank you very much. We really appreciate
Thank
you
you.
being here, and
Cool. Yeah, I like it too. Thank you.
cheers.